It's Windless Nerd Out time! How you guys doing today? Happy Windless Nerd Out time, you guys. And today we got a special treat for Beethoven and J-Mo. Sit, you guys. Who wants a treat? One for you, one for you. We got a treat for you too, though. We're going to be talking about growth hormone today. And who doesn't want to be hearing about growth hormone, right? You hear about it all the time. What does it actually do? How is it formed? What promotes the release of growth hormone? And what is IGF-1 and how does it play a role in skeletal muscle hypertrophy? We're going to talk about all that good stuff today, but before we get into it, I want to say happy 50th birthday, Paulo Silva. Happy birthday, my brother. I hope you are having a fantastic day. This one is absolutely for you. We'll talk about him more at the end, but as for now, let's get into our discussion about growth hormone. So where do we start? Well, where do we start usually when we talk about these hormones, as we did with testosterone, right? Well, when we talk about growth hormone, you guessed it, it is the hypothalamus, and specifically the arcuate nucleus in the hypothalamus, which produces growth hormone releasing hormone, or GHRH. And when GHRH is produced, it then travels down the hypophyseal trunk, or we could say through the hypophyseal portal system, to the adenohypophysis, aka the anterior pituitary gland. And when we get to the anterior pituitary gland, GHRH promotes the release from what are called somatotropes. Again, somatotropes are in the anterior pituitary gland, or the adenohypophysis, right? Release growth hormone, right? So now we have growth hormone released from these somatotropes in the anterior pituitary, and where is it going to go? Well, some travels through the blood to other tissues, right? Some specifically goes right to the liver to be converted to IGF-1, and we're going to talk about the IGF-1 pathway today. But before we do, thank you guys for tuning in. I hope you enjoy this. I'm going to see real quick who it is. Kippy, what's up, buddy? How you doing, man? Love you, man. Something carried me toward the camera to see. Usually I check at the end, you know. Before we talk about IGF-1 at all, what's up? Let's talk about what stimulates the release of growth hormone in itself in the first place, right? So a few things can. One is a high amount of amino acids in the blood. Another is a low amount, again, a low amount of fatty acids in the blood. A low amount of sugar in the blood, so low blood sugar, low fatty acids in the blood, high amount of amino acids in the blood, or healthy stressors. And what is the primary healthy stressor that comes to mind first, right? It's exercise. It's definitely exercise, right? So exercise is a huge promoter of growth hormone release. Yet another reason you should be getting it in just about every day, folks, in some fashion, right? So now we have our growth hormone that is being released from the anterior pituitary gland, and it travels to the liver. When it gets to the liver, it binds to cell surface receptors, and when we have this growth hormone binding cell surface receptors in the liver, it triggers an intracellular cascade, and more specifically, it triggers what's called our JAK-STAT cascade. And so what happens is it binds that receptor, and that promotes the intracellular phosphorylation of JAK, or Jonas kinase, after some other enzymes are phosphorylated. But our major point here is we get this phosphorylation of Jonas kinase. And when we talk about a kinase, well, kinases, they promote the phosphorylation of other things, right? So it makes sense that Jonas kinase, or JAK, in our JAK-STAT pathway, and again, we're in the liver here, right? It makes sense that Jonas kinase goes and phosphorylates what's called STAT, or our signal transducer activator of transcription, right? And so the name precedes itself, does the name for STAT, right? Signal transducer activator of transcription, right? So what is transcription, right? Transcription is the conversion of information in the form of DNA to our messenger RNA, which happens, in the nucleus, right? So now we have active phosphorylated STAT, which goes and travels to our nucleus, and STAT gets there and it promotes, again, transcription, right? So it promotes the conversion of, it binds to that DNA strand and it promotes the conversion of information in the form of DNA to messenger RNA, right? And then our messenger RNA can now travel outside of the nucleus and it can go to the ribosomes and become protein through a process called translation, right? So again, that messenger RNA is then translated into protein via the ribosomes, right? So now we have this protein, okay? And this protein is going to go and become further modified in the rough ER and the Golgi apparatus. And after that happens, we get IGF-1, baby. We made it. Finally, IGF-1, or insulin-like growth factor 1. So now that we have insulin-like growth factor 1, it is released out from the liver and it travels to our skeletal muscles, right? The biceps being one of them. And when it gets to the skeletal muscle, does IGF-1. It binds to a cell surface receptor, analogous to growth hormone in the liver, as we were just talking about. And when IGF-1 binds a cell surface receptor of the skeletal muscle, it promotes another intracellular cascade. And we won't get into any intermediates and things like that. Just know it's the same type of thing going on. There's some intracellular phosphorylation. We have transcription factors going to the nucleus, promoting transcription, right? So we're getting our messenger RNA now. And then that messenger RNA is converted into protein via ribosomes, right? And through the process of translation outside the nucleus. And so now after it is further modified in the rough ER and Golgi, we have these proteins intracellularly in the skeletal muscle, that is, right? We're inside the skeletal muscle now. And these proteins will travel back to the internal portion of the skeletal muscle cell membrane, okay? And when these proteins get to the internal portion of the cell membrane, they promote another phosphorylation cascade, which actually super interestingly promotes the opening of amino acid channels. And why did I get so excited about that? Because it's so cool, because it makes so much sense that when we have high amounts of amino acids in the blood, it promotes growth hormone release, right? And this growth hormone release now had eventually, a bug got in my pants, it's wild, eventually, right, led us here to IGF-1 promoting this happening in the skeletal muscle. And so, it's crazy. And so now we have these amino acid channels open and they can influx into our skeletal muscle. So now what could happen when these amino acids get into the skeletal muscle? Well, when the amino acids get in there, we know that they're the building blocks of what? Proteins. That's right. Right? They are a bunch of monomers that form a polymer or connection, right? And we get a protein, okay? And when we get these proteins, now this is how we have what's called muscle protein synthesis occurring. And we literally just described how that happened, right? From top to bottom. And, again, them being synthesized, these proteins, from amino acids, which were, entering the cell as a byproduct of that protein getting to the internal portion of the skeletal muscle cell membrane, which was produced as a byproduct of IGF-1 binding to the skeletal muscle cell surface receptor in the first place. So now we have this muscle protein synthesis going on, and with this muscle protein synthesis, we get increased skeletal muscle size, and it promotes skeletal muscle function as well. So this is how growth hormone can promote the production of IGF-1 and hence skeletal muscle hypertrophy or muscle growth, we could say. And I thought that was pretty cool, you guys. So that's all we're going to talk about today. I don't want to throw too much at once at you. We'll continue growth hormone tomorrow, but I'm super excited to talk about it. Just know that. So I had a great time today. Who else do we got on here? Gino, what's up, baby? How you doing? Go get some amino acids in your blood and get that growth hormone pumping, baby. With some exercise too. Yeah. And if you're late to the party, low amount of fatty acids and sugar in the blood also, right? And healthy stressors, right? Aside from just exercise. So before we go, we got to say, happy birthday, Paulo Silva. Happy birthday, brother. You're 50 today? It's crazy, man. You have such a young spirit. I can't believe you're 50. Not that 50's old, You're like, damn, that was cold, Nah, man, you look young, you act young, you're young at heart. You're a great guy, Paul. You're always a good time, man. Every time Paul comes through the door, you know he's there. You could be in the other room and you could just feel the energy, and you could hear him. Paul, he's always got good stuff to say. You're always, dude, there's never a dull moment with you, man. You brighten up the room, you really do. And, I'm glad that I got to meet you. And, I hope you're having a good time down there in Florida. I'm sure you are. It's a nice free country down there. I hope you're enjoying it. And, hey, man, I want you to know 100,000%. This one is forever your day in the book of When Wellness. So have a very, very, very happy, great, fantastic rest of your birthday. This one, once again, is for you. Love you, man. And, I really hope you enjoyed it. So hope you enjoyed the discussion, too, on growth hormone. I sure did, right? I'll say it again. So thank you guys very much. Yeah, that's right, Gino. Amino acids, baby. Have a great rest of your night. We'll see you tomorrow. We'll be talking more about growth hormone. If you want to hear about it, you tune in sometime then. Not sure where, not sure when, but I'll see you then, you guys. Have a great rest of your night. Thank you, and happy When Wellness.